Hi everyone. Today we're going to be talking about how to measure cost avoidance using aPriori and some of its available resources like our tool AP Analytics. My name is Emily Matsko. I'm a senior expert services consultant at aPriori, and I've been in this role for almost 3 years now, working with a variety of customers to address different use cases, including the cost avoidance and design use case. And then later on in the presentation, you'll also hear from my colleague, Abe Chavez, who is a principal consultant here at aPriori, and he'll talk a little bit more about some of the custom reporting options we have available for cost avoidance. So getting right into it, to introduce this topic, we're going to start with an introduction to cost avoidance. What is cost avoidance and how we're going to be defining that today as we talk through some of the tools available, and also the use case where cost avoidance is going to be applicable. Then we'll move right into aPriori's out-of-the-box reporting solutions that are available to assist in measuring cost avoidance. And we'll wrap up with some custom reporting options that have been used by customers in the past to measure cost avoidance as well as DFM risk. So starting off, what is cost avoidance? And really, cost avoidance is going to apply to kind of one of our major use cases here. So as we know, aPriori has a few different applications and use cases, two of which being sourcing and quoting, where sourcing is where aPriori is used to identify cost outliers and really guide negotiations. And really how we're measuring success within sourcing is going to be realized savings. With quoting, we're using aPriori to derive product quotes, and our success measurement is going to be, increased revenue or decreased turnaround time for a quote. But really where we're going to focus this presentation on and where cost avoidance is going to be a big component is the design use case. So as design engineers, we can use aPriori to identify DFM risks, so design for manufacturing risks in designs, conduct trade studies, and drive design iterations, as well as design out some of the unnecessary costs that we sometimes see. And so the success measurement for the design use case is actually going to be this cost avoidance that we're talking about. And really what that is, how much cost have we or how much have we reduced the cost of a design from kind of the initial to final design and throughout these iterations. So cost avoidance can capture cost reduction from preliminary design to final design, as well as within the design process at different kind of stage gates and checkpoints. And when we talk about this design process, I'm going to walk through what that looks like as a full process. And really what we'll be using today to guide this discussion of cost avoidance and analysis is a pretty boiled down version of what we might actually see in the design process. So within these kind of three categories, in real life, we're going to have different stage gates and design checkpoints and kind of more formal different categories. But for the case of this presentation, we're really going to focus on kind of the three main stages, being preliminary design, which is where we're going to see some of our requirement scoping and initial design development. And so as an example, this might be, just a prototype phase. We might not necessarily have CAD files. It'd be like having a paper airplane when you're tasked with designing an airplane. Then we'll kind of get into this iterative process and start conducting our trade studies. Maybe we actually have a CAD model at this point. And as we know, as design engineers, we can all maybe be a little bit overzealous. So when we're starting out this process and add every bell and whistle under the sun. And really what aPriori can help do and what this cost avoidance measurement can help do is drive some of the decisions to design out that extra cost that a lot of those nice to have features but maybe aren't required kind of add to a design. So during these iterations, aPriori can measure, the delta between different trade studies, help drive some design to decrease DFM risk, cycle time, and so on and so forth. And, as kind of an example, it's like going from our paper airplane that we started with to now our rocket ship. And so what we want to use aPriori for is to get from that rocket ship to our final design, which would be somewhere in the middle, kind of a standard airplane maybe. Using aPriori feedback, we can kind of get to this point, and then between our rocket ship and our airplane, we can measure some of that cost avoidance that we were able to successfully design out using AP, and then also kind of attributing our success or quantifying our success with that cost avoidance value. So tracking your project's cost avoidance over time. So shortly, I'm going to actually jump into our aPriori analytics tool to walk through how to actually measure cost avoidance using our out-of-the-box reports. But before I do that, I just want to introduce kind of the two scenarios where we're going to run these reports. So aPriori does have two out-of-the-box reports available for cost avoidance. The first one is really going to address, what is the difference in cost between the initial and the final scenario. And so it's going to compare two design versions after making design changes and conduct trade studies. So that's using our kind of airplane example. That would be like saying, okay, we started with a rocket ship and now we have our final design. So initial to final, exactly what is the cost difference there over the entire course of our design phase and iteration phase. And so really that's just going to compare A to B, and that's going to be that first report that we walk through. The second report is going to be a slightly more automated cost avoidance measurement tool. And so that's going to be similar to looking at, okay, we have one scenario, one situation, we have our first design, we have now made changes to it. Let's run this report, right? And then we make changes to it again. Okay, let's see how much additional cost avoidance, what is the delta between our third iteration and the original design we had. And you can run it kind of constantly at these different stage gates throughout the process. So again, using our kind of airplane example, say you have, your initial rocket ship, you make a couple material changes. So then you run this report and it will give you just a cost delta between the most recently costed scenario of this part to the highest cost scenario of this part. And then we actually make some design changes from there, change the CAD model a little bit, maybe remove some of the extra, those bells and whistles we were talking about. And then we can run this report again. And now we're going to be comparing kind of that, let's say, third or kind of redesigned part to the highest cost version of whatever that was. And so I'll walk through exactly how to run these reports and what they look like, but those are the situations. So the first report we'll talk about, like I said, will really just be comparing, design one to design final. And then the second one we'll talk about will be really comparing or give you the ability to compare or measure cost avoidance intermittently throughout your iteration process. And so just as an introduction, this is what the report's going to look like. Again, I'll jump into our AP analytics in just a second here. But really kind of what this all boils down to is based on cost differences between scenarios and aPriori. Both the basic cost avoidance and the automated cost avoidance reports will calculate total and annualized cost avoidance across components. So with that, I am going to move over into our reporting tool. So you guys should be familiar with our AP Analytics platform. And so these reports, as I mentioned, are going to be in our out-of-the-box reporting folder. So if we open that up, And then if we just search for avoidance here, we'll see two options. And so these are the two options I was just talking about or just introducing. So we'll start with our basic cost avoidance report. And the basic cost avoidance report is going to display cost avoidance across all components in the reporting database that meet the prerequisites. So whereas some out-of-the-box reports will see you run on a very specific roll-up or a specific export set, the basic cost avoidance, based on the parameters given, will take any and all scenarios from the reporting database that match the prerequisites. And those true prerequisites are a consistent part number and scenario type. So you can't compare a part to an assembly, say. And then the second one is that the part has to have an initial scenario and a final scenario. And so the scenario name has to very strictly be initial and final to compare across. So aPriori will go into the reporting database, say, okay, I found this part number, it has an initial scenario. If it also has a final scenario, it will output the results of the cost delta between those two scenarios. So when you're setting up this report, you do have a few options here with your input. So you can change the earliest cost date of that final scenario and the latest cost date. The latest cost date will always default to today or today's date and time, but you can always change the earliest cost date. So maybe you only want to evaluate parts that you've costed over the last week or month or 3 months. Either way, you can change that to limit the amount of data being pulled in. And then the cost metric, of course, you can compare piece part cost, fully burdened cost, or our total variable cost within aPriori across these scenarios. And then you can, currency code, sort order, all of those kind of standard options there. But setup is awfully easy. You can just hit OK here. And aPriori is going to come up with this list, which shows you the parts that had that initial and final scenario available. And we'll sort them based on annualized cost avoidance. So this top row is going to be our highest cost avoidance for the year at $1.5 million. And this little asterisk to the left shows us that they have different costing inputs. So maybe this cost avoidance is just driven by a change in annual volume or a change in material type. And so all of the inputs that you see here in this chart, digital factory, process group, material composition, and annual volume, that is all coming from the final scenario. So the part with scenario name final will output the cost inputs here. And so you can see kind of where you landed on the final design. And then you'll also notice, down at the bottom, we even have a part that maybe went up in price, and maybe that was driven by a material choice or some tolerance requirement that we didn't have in our initial design. But overall, we're kind of net positive here with our cost avoidance between our initial and final scenarios of these parts. So again, this is really just comparing, okay, we have one part number with its scenario name initial, so that's that rocket ship, that first part or first CAD file that you have going through the design process, and then comparing it to the final design, which is our airplane. We finished this, we're going to customer design review, we're ready to go to production. What have we improved on? And that's where you'll see the annualized cost avoidance. All right. And then going back, so our second scenario that I touched on was this is going to leverage the automated cost avoidance report. So where I was talking about, the first one we went through is going to compare part or scenario A to scenario B and just give you a delta. The automated cost avoidance report can be used a little bit more easily when you're trying to do pretty rapid iterations on a scenario and a part. And so what the automated cost avoidance report does is it also displays cost avoidance across all qualifying components. And the prerequisites for this report are a little bit different. It has to be the same part number and scenario type again, so you can't compare parts to assemblies. You also have to have consistent scenario names across the same part number. So whereas in the last report, the scenario names had to be something very specific, this you can name whatever scenario name you want. It just has to stay the same. And what aPriori is going to do is from the cost export that it has, it's going to search all parts in the database based on the parameters and the constraints we give it, and then say, this is the latest cost scenario, just the most recent cost data compared to the highest cost scenario. So the scenario that aPriori says, okay, this is the highest cost in our reporting database that we found for the same part number and same scenario. And so this does have a few more setup options with the report because we can set a few more parameters here. And because we're not specifically looking for, those very specific scenario names, we're looking for any scenario name, this kind of limits what it gets read into this report. So as an example, you can sort based on, component type. We're just going to do parts today as an example. And then you can also filter based on if costing inputs match. So say you only want to compare parts that are in the same process group from the reporting database. You can select that. You could also select based on material composition. So say you don't want to compare parts where material inputs are really driving some of that cost avoidance. You really just want to get some cost avoidance data for the design itself. You could select, okay, every component must have the same material composition. Today, we're just going to go through process group, and then excluding cost failures. That just cleans up the data a little bit. And then costed by full name. And so this feature, I do really like the costed by full name because you can filter based on who is actually analyzing these in aPriori. So as an example, if you're a project manager for a design team and you have, let's say, 4 people on your team, all kind of responsible for sub-assemblies within a larger program, you can filter on either each of them individually to look at the parts that, is just part of one subcomponent. You can also look at the parts that are costed by all 4 of those individuals, or say you just want to see everything that's been costed in that environment. You can also kind of not filter on this. For the case of this example, I am going to filter on just parts I have costed instead of the, entire aPriori organization. And then again, I am going to filter based on process group. So I only want to look at sheet metal parts here. And then you can also filter on the digital factory. I'm not going to today, but we do have all of those available. And of course, if you have custom digital factories for your organization, those will show up here as well. And then we're just going to click OK. And so you'll notice, again, sorted by annualized cost avoidance. And we have one really good example of, this component is showing $1,000 in cost avoidance, potentially driven by cost inputs. But what that's saying is, okay, we have this component name and we had a scenario, and that initial scenario was, or whatever the name of that scenario was. In this case, I know it is initial. The highest cost that we saw in the reporting base was the 17 cents. But then the last cost we did on this part was actually only 11 cents. So that's where that cost avoidance comes in. And again, this is because you don't have to have a really strict scenario naming convention and can name it whatever you want. This makes running this report as you make kind of more nuanced or smaller changes to a part throughout iterations, makes it really easy to run pretty frequently. So you can kind of get a checkpoint or just kind of a gut check on where you are with your design at different points throughout the process. And next, I am going to hand this over to Abe to talk about some of our custom reporting options that we have using the AP Analytics tool to measure cost avoidance.
Thank you, Emily. For you guys that are design engineers in the audience, would you like to see how your design is progressing in terms of cost and weight throughout the design process? I will show you how to track the progress of your aPriori project throughout all those iterations that Emily was talking about, right? And I will show you how to do it automatically and how you can call the scenarios anything you want. You don't have to call it initial and final. And you can actually name the component that you are designing and that you're going to track, anything that makes sense to you and your management, right? So if you are responsible for designing an assembly and the name of the assembly, obviously you have a CAD number for it, and it's just some, A508-001, for example, here. You can just call it luxury car seat, or that may be F-150 front bumper assembly, whatever makes sense, so that people know what is it that they're looking at. And then you're going to be able to drill down into the parts of that assembly so that you know which ones are the biggest contributors to either weight or cost, right? And you know what to attack. Okay, so let me show you how that's going to work in the product. So again, we're taking you here to the aPriori Analytics product. You are going to go into the ad hoc views because this report doesn't come out of the box, but we can create it for you easily enough. And if you have expert services, that should be a fairly short task. We have called this report cost and weight tracking over time. All right, and so the report will show you the cost and the weight of an assembly as it moves through different time periods here. On the black bars here are your cost, and the scale for that is over here on the left, and the red bars are the weight, and the scale is over here on the left. And you can look at each one of these independently. So I can turn off weight and look at just cost and see how cost is moving over time, or I can turn off the cost and see the weight and see how the weight actually increased in the beginning, and then we figured out how to get it back down again, right? You can see that my time periods here are daily, and that's just because I have to create a set of data and then make changes quickly. But you can actually make this grouping. You can make it daily, you can make it yearly, quarterly, monthly. You can go all the way down to hourly or by the minute, which obviously you don't want to do. But what the system wants to know is, what do you want me to plot? So if you're plotting this monthly, do you want me to plot the maximum cost over that month, the minimum cost over that month, the average, or the maximum weight, the minimum weight? And so you simply would right click and then you could change what is it that you want the system to plot over here. You can also see here that I have selected a time period. So you can say over the last 6 months, I want to see this, how my component has been tracking over the last 6 months, monthly, basically, or over the last year, quarterly. And then, as promised, you can look at the assembly, or you can look at the parts inside the assembly. So I can select part, and I can select apply. And now what I'm looking at is exactly the same assembly, except that I'm looking at the parts inside of it. So you see more data points within the same time periods over here at the bottom. And now, right now it becomes more useful to actually turn some of these off so that it makes them more clear, because it's a little confusing when you have more data. So now I can turn the weight off and see how the cost progress, and I can see that obviously in the beginning, these were my two most my two highest contributors to cost. And if I'm an engineer and I'm trying to cost reduce this component, this is very useful information, because now I know if I really want to make an impact, I don't go after this components over here. That's not going to do diddly, right? I want to go after the ones that cost the most. And that's what happened, right? So I went after those. Then I went after some of the little ones. And then I went after this big one over here, right? And you can see how the weight progressed. I did reduce the cost, but I increased the weight in doing that. And so I had to somehow figure out how to reduce the weight at the end. And so you can see both how your cost and your weight is progressing through time. So this is for an assembly. I can also look at a collection of parts, because sometimes you're responsible for single parts, right? And you're responsible for a collection of single parts. So you might, for example, be the engineer that's responsible for all the castings inside a product, or all the machine parts inside a product, instead of a subcomponent or a subassembly. And so what you can do is, this is just a collection of machine parts, basically. And I can look at them at that's at the part level, but I can look at them at the whole roll-up level. So if these are all the machine parts in a particular product that I'm responsible for, I can see how my collection of parts is tracking. And then I can look at, again, I can look at the part level and see how they're tracking individually, right? Both in weight and in cost and weight. All right, let's move on. That's tracking the cost and the weight of a component in time. What about tracking it as it progresses at discrete points in time, following your design process, following your design stage gate system, basically? Well, we can also do that, right? So we can show you how you can easily track the cost and weight of anything that you're designing at the different stages of your MPI process. This one is not automatic. The other one, all I had to do is basically create that export for the assembly that I was tracking, or the collection of parts that I was tracking, the car seat, for example, export it once. And at the time that it's exported, you tell the system export every week or every month, right? Or every day. I wouldn't do it every day, but, and then just run the report whenever you want. Just give it the date range and it runs automatically. So you actually, in this one, you actually have to save an instance of whatever it is you are designing, and then add it to a roll-up every time that you save a new one, so that what you're really tracking is the component as it moves through the stage gate process, because you keep adding that scenario, is what we call the instance, a scenario, to the roll-up. And so let me show you what I mean. So this is really what you're going to be looking at. This is what I'm going to be showing you. The hitch is just an assembly, basically. And I basically saved a copy of that assembly when I went for my concept review, and I called it concept release, right? You can call it concept review. And then when you go for your stage 1 review, I saved another copy and I called it a stage 1, and I put it inside this roll-up, right? You can call it gate 1. You can call it whatever your process calls those stages. And then the last one I did was this, stage 3 release. It could be release candidate. It could be release candidate 1, release candidate 2, whatever makes sense to you. The point is that every time that you you save a stage, or you save this instance, you add it to this rollup, and as this rollup grows, you are going to be tracking the cost as it happened, right? So let me show you what I mean by tracking the cost as it happened. We're going to go to the same spot, ad hoc views, and we're going to select cost and weight tracking at stage gate. And you're going to see here is the same data in the same format, and I have this hitch here, and I have, instead of having dates over here, what I have is the different stages, because what I'm tracking is that roll-up, that container that has the different instances, the different scenarios of that assembly in it. And so here you can see that in the very beginning, you know, I just as typically happens, I got my concept design. I haven't put a lot of I haven't done, you know, full FEA yet. I haven't, you know, maybe put some of the tighter tolerances in and things like that. And so typically your cost goes up, and then you have to figure out how to bring that down. Right? And so this is what happened here. And similarly, as I did before, I can look at this at the part level. And this one has got a lot more data, so it might be a little more confusing to see. And then obviously the more parts you have, the more crowded this gets at every one of these stages. But I can just turn one off and I can see how my cost started out low. And you can see that this is the last part of the group, and then we start all over again. I can see this part got really expensive, right? And then I managed to bring it down a little, but then I did something to another part that went up in cost, and so I had to bring that down. But you can track the progress here and see how your design is behaving and progressing along. Same thing for the weight. And so exactly the same data, except that this time, instead of having dates here, I have the different stages, and I have something manual to do. I have to save a copy, essentially, of my assembly or whatever it is I'm designing at every stage, and then add it to this roll-up. That shouldn't be a big deal, though, because you have to go to this review, and you have to have something to present at this review. So you're just saving that at that instance in time, you're saving whatever it is you're reviewing. Okay. So I was in engineering for 7 or 8 years, and I know, and you know, that the quality of your design, the quality of whatever it is you're designing, takes precedence over cost. We don't want this type of stuff to happen, right? And so, how would you like to be able to track your manufacturability and quality risks, issues over time as your design is progressing, and see if the more complex your design gets, the more issues you have, and what are those issues, and what are you doing to resolve them? And so that's what this report's going to do for you. It's going to allow you to track the number of DFM issues that are present in your design as it moves through time. It is also automatic. You can use the same export. So the same export that you used to track cost and weight can be used to track DFM issues. It's just simply a different report that will be applied to the same data, basically. Okay. The only caveat to these reports is that the report looks at a group of parts that is made from the same process. So sheet metal parts, machine parts, plastic parts, all will be looked at differently with a different report. So you're going to have a machining DFM issues report, a sheet metal DFM issues report, injection molding DFM issues report, and that's because the manufacturability issues of a plastic part are much different than a sheet metal part. And so that's why you need to run different reports. But you can have different type of parts in the data set. So I can have an assembly, and I will show you that. I can have an assembly that has pattern tube parts and sheet metal parts and machine parts and plastic parts. And if you put it through the right report, it's only going to show you the sheet metal parts when it's showing you the DFM issues for sheet metal. It's only going to show you the plastic parts when it's showing you the DFM issues for plastic. So let's see how that works. All right. So what I have here is a very simple roll-up made up of just two different sheet metal parts. And what the report is doing is looking at that roll-up, and it's looking at it at different points in time. I only exported it 3 times, basically. And I made some design changes as I went along. And you can see here that the 2 parts that I have in the roll-up is this aPriori 1 and this bracket 0. And when I started day 1 here, I had 4 hole issues on this one, and that was it. And this one I had a ton of issues. I had 51 hole issues, which is, by the way, things like the hole might be too small. If the part is made on a turret, for example, or is stamped, maybe there are holes that are too small and the pins are going to break, right? So something like that. It had 42 proximity issues. Things like, hey, there is a hole that is too close to a band, and so it might deform when you make the band, right? There is a hole that is too close to an edge, and it might not be enough meat, and that might crack, right? So these are quality risks and DFM issues and quality risks, okay? And so I can see that I did something to my designs, and instead of fixing this turret, this turret part actually made it worse. So that's feedback I get here. This part, I actually did pretty good. I brought down from 51 to 27 on my hole issues, and then my proximity issues, I brought them down to 12 from 42, right? So great progress there. So then I did something the 3rd day, and I brought this one down to 4. I decided, hey, I'm gonna just keep with my old design. That was good enough. And this one, on the 3rd day, I couldn't do much more about these issues, but I traded essentially all my proximity issues for 6 bend issues, which might be, a bend that might be too tight, right? And you might crack the material if the bend is not aligned properly, for example. The lip on a bend might be too short, things like that, okay? So yeah, I got rid of all of these proximity issues, but I created new ones, right? And so I need to keep on looking at this. Point is, you can have a collection of parts or an assembly. I'm going to show you that hitch again. So if I run this on the hitch assembly, I can see all the parts on the hitch, right? And I can see the type of sheet metal issues that I have on those sheet metal parts, okay? Some of these parts are not sheet metal, and so they're not going to show sheet metal issues. For example, this shaft is a machine part. There is a plastic part in here somewhere. Things like that, right? And so, but what I'm trying to show you by doing this is that this assembly is not all made up of sheet metal parts. You don't have to worry about that. The report will recognize that some of them are not sheet metal and only report on the sheet metal ones. If there were machine issues on this shaft here and I ran a machining report, I would get issues on that. Unfortunately, this doesn't have machining issues. It's a pretty clean design. All right. We come to the end of the presentation. We have shown you 5 different ways in which you can look at the cost and the weight of your assemblies, and even a way to track the manufacturability of your assemblies or your parts that you are designing for different use cases. So we hope that this has been practical and fruitful for you. Thank you very much and have a great day.